building a data engineering project. Let's continue what we started in the last video, where if you recall, we were working on healthcare data. And now we're going to kind of expand it a little bit, because as I was looking at the data, I realized there's data from 2008, there's data from more recently, and it actually causes a lot of problems that I think are very relevant to data engineers. If I were to take both of these data sets, they're both synthetic data sets created by CMS. In turn, they both are required to have certain data points, but they are set up in different ways. For example, the way procedures are handled in one data set, I want to say it is the more current one, claim or procedures are handled in line items. So you actually see the line items with procedures, whereas in the prior data set, they did procedure codes very what is considered the wide format. So now you have to do some actual data engineering. Nothing that is beyond ordinary, but you actually have to think about that. You have to say, hey, one data set looks like this, the other one looks like this. And both of these data sets represent the same information, but we need to somehow standardize it. And that's important because we're talking about now, I'm going to add kind of another layer to this, building a product. In particular, I'm going to use the term building $1 million product. And I'll kind of explain that as we go along. But as someone that's helped and also built these products in the past, these are things you can build. There are a lot of opportunities in different industries. And again, we'll talk about that as we're going on, that you can actually build these products. In fact, this exact product we're building with this healthcare example is stuff that I've built in the past. Obviously, it's not going to be the exact same thing, but it'll be in the spirit of it. It'll be a real thing. And then you could take it and apply it onto your own future projects, right? Like if you're an expert in a certain domain, you could actually build something and create a product, and in turn, who knows, make money. And there's a lot of products like this you don't even realize exist. That's the funny thing, is like there's a lot of these products that go under the radar. No one realizes they exist because they're in specific domains, and these companies just happily make money with very small staff because you generally don't need a huge staff to manage it. And so we're starting with a project, but hey, who knows, if you've got a good idea based off this, go and make it your own. It doesn't have to be with healthcare data again, but you're gonna be following very similar principles that we are in this video. So with that, let's dive into the code and actually doing stuff. There's a ton to go over. This video is a little longer. Also, I'll be posting this on GitHub eventually, so you will be able to, hopefully, if you want, maybe help me along, because I'm usually just doing this when I have free time to actually put this project together. And I believe, unlike many other projects that are going to kind of sound a little more cookie cutter, this will sound unique going on your resume. So with that, let's dive in. All right, let's dive into actually building this data product. Again, in theory, could it be worth millions of dollars? Yes. I've worked for several companies that have done this and have products that are doing quite well. And we'll talk about kind of some of the challenges you'll face later on in the video, as well as talk about a diagram in terms of like the design and why we're going to be doing a lot of this extra lifting initially, and why it benefits you in the long run. So you can kind of see in this script, I hard-coded the file path here. What I imagine here is you'd probably pass this via Event Bridge or something similar. Some sort of trigger would fire it off and tell you, hey, I got a new file. Here's the file name. And you probably get this file, depending on the company, depending on how often they need this reporting, anywhere from once a day to once a week to once a month. Again, everyone doesn't necessarily need as real time as they think they need. And basically what we want to do is, based off this file name, is figure out, well, what SQL script do we want, right? Like which SQL script should we start with? Because again, let's say you've got 100 customers, you don't want to write 100 DAGs that all do the same thing, but are, slightly different, right? You have a different SQL file for each 100 DAGs. We want to create a standardized DAG that will then run. We'll figure out, that's what this first task will do. And it's in function. We'll go below where it actually is, but that's what this first function will do, is it will actually figure out or find which SQL script we should actually be running. Basically, the way this operates, I have this create script. It's a basic, just create script. That's some customer SQL mapping. You can imagine there's like a customer ID in here too, if you want. But for now, we're going to keep it simple. We've got the CSV file name. This could be more of like customer name, honestly, and SQL file name. And we have this insert script that basically says customer one and then maps to some SQL file. In theory, if you're really good about this, you could just set it to look for the SQL files that match the pattern of the customer name. Again, that's assuming you're really good about it. If not, you've got to use some sort of mapping table. The other thing you can imagine here is you probably have a version field in here too, right? To say like, hey, this is version 1 and we haven't changed it, because it will change at some point. And it's nice to keep track of all those files, because if you want to ever run your old scripts again and backfill, you're gonna want those old SQL scripts. So don't want to delete them. You do want to keep those versions somewhere. Both of these run when I run my Docker Compose, so we don't actually have to worry about it. So again, we've got Docker Compose and it's running a database here. that has that create script that I had. We've got the file name being passed, which is just the base name. So it just takes this customer name here. And after the connection here, we've got this db config. It connects to the database down here. Once it connects, then all it's going to really be doing, all it's trying to do is, again, find that mapping, right? We want to say like, okay, where is this mapping? What's the SQL script we're going to be running? We return it back, and if it can't find it, it's going to let us know. Actually, I just realized I removed the try and catch because I was trying to figure out the errors earlier. Buffer down, it prints out and executes the script, fetches the result, which should only have one, and I can get rid of some of these prints, and then returns the file name, right? Because we want the file name of the SQL script later on because we need to run it. But let's talk about why we're doing all this, right? I want to kind of go over the higher level design before diving deeper. So what you can imagine, right, is we have these files that are coming in. The other thing I didn't add was having some sort of, I have some date stamped in the file name. All this will be passed in to your customers who you tell how to create these file names because it will make it easier, where you're going to have, the customer name, the entity likely, and then depending on how often you ingest these files, some date. If you're doing it once a month, what I'd suggest is you just give it the first month or the first day of the month or the end, pick either or, because that way, when we run the scripts later on, you delete that data if you get it later on in the month. You want to make sure you're not duplicating data, and that's one way to do it. So it depends on, again, how often you insert that data. But if it's once a month, just in case they have to resend it, keep it a standardized date. So that way, regardless of what date they send it during the month, it removes the old version of that data and replaces it. Then you have some sort of standardization that occurs. I say DAG. It is some process that occurs that takes all these names, right, and standardizes them. And this is an example, right? This is why I'm doing the CMS 2008 to 2010 data, comparing it or ingesting it with the other data set, both synthetic data sets, because they have different structures. They have different naming. They have different ways they approach dates. One has pipe delimited, one CSV. All of that has to be standardized. And it could be way worse, right? Like sometimes you might have the actual date of the event be split up into 3 different fields. So you have to have some sort of standardization script that creates one schema for claims, right? You don't want to have 8 different schemas for claims and then have to build 8 different processes to handle, your product development. Your goal is to create one standardized data warehouse that has all of your customers in it, right? You want hundreds of customers in there. You want to create one standardized DAC. And from there, you've got a ton of products that you can build, right? The obvious one is things like dashboards and metrics, right? You can just give these people dashboards and metrics. This is where, again, I've seen lots of companies do this, where they just give pretty standardized metrics just in a better way than many of the products do, right? Like, I think I saw someone recently post out that like Stripe's dashboard is terrible, or I don't remember which dashboard, but someone's dashboard was bad, and they see why people pull out the data. I don't want to call it a specific company, but I remember it was some finance company. You might also develop something like a forecasting model that way they don't have to pay someone to do it. So if you're charging them $500 a month for a product, guess what? They don't have to pay someone that money to do forecasting. They can just pay her for a product. You might have an algorithm that you create. For example, when I worked and did this in healthcare, we did like fraud detection algorithms that we would be able to apply massively towards tons of insurance providers rather than just one insurance provider. So you get this economies of scale where, you can get a team of 3 to 5 to maybe 6 people building these products that companies might pay, their own 6 people to go off and build and might not get results. And you're like, hey, day one, we have results because we already have a process in place and it's worked for so many companies. The other product that's probably one of the most valuable is benchmarking. So because you have all of these companies' data sets in one data warehouse, you can benchmark them against all the other companies' data sets, right? Obviously, there's some privacy and security things you need to deal with when you do that. You probably have to ask for permission and be like, hey, if you want these benchmarking results where we compare you to other similar sized companies, or we let you know as an insurance company how often your healthcare providers are doing emergency services compared to other healthcare systems. If you want that, you have to be part of this benchmarking, right? And generally, if they really want that, they're going to be part of it. But again, there are legal things you have to deal with there. So I'm saying that that's an option. It's one of the most valuable things you can offer, especially if you've got like hundreds of companies in there. You're offering something that they would never get. They can never get this because they would not be able to get data from their competitors. So you can give that to them, and that's very valuable. Now, I've seen this exist for a few different companies, and I've worked on it for a few different companies. Insurance is one example. Healthcare in particular, again, that's where I've spent a lot of time. I've seen that now for 2 different companies that kind of do this kind of work. Casinos, lending and banking. E-commerce was another big one. That company had so many companies that they were managing. The difference was instead of files, they were directly connecting to APIs. And in some cases, still files, because that's how some companies pass the data. But yeah, they did some APIs. I've seen barbershops doing this, like not barbershops themselves, but a company that provided analytics for barbershops. The key is the economics, right? Like obviously, one, I think the fair question, if you're watching this video, is like, why don't I do this? Why don't I build this product? One, in consulting is guaranteed money to a degree, as long as your customers don't go out of business. You don't take the risk of spending a year to build a product that you hope will eventually work. And that goes with anything, right? If you want to do this, it is risky. In fact, if you were to do this, what I'd recommend you do is do consulting first. Try to really niche in a specific area. And that way you have some customers who already like working with you, and you can then start offering them the service, and then you can use their data to build your product, because the data has to come from somewhere, and then you can build the product. So you're probably gonna have to focus on a specific area. But let's go over kind of the math here of kind of what you might need, right? Like let's say you got 100, let's say you're doing casinos. So I don't even know if there's 100 casinos in America, but let's say there's 100, or like 100 specific companies that are probably not big enough, that are probably like that good middle ground where they're not huge, but they're not so small that they never pay for this, but they're not so big that they have their own data teams, because that's probably who you're targeting. There's probably 100 casinos, but I have to Google that. So let's say 100 casinos. Let's say you charge them $500 a month. Honestly, that's not that bad if you're offering them the equivalent of, let's say, half an analyst's time. You're making, right, $50,000 a month, which translates to $600,000 a year. And I know companies that are probably doing more than this with maybe a few employees. So they're probably doing, maybe they're charging maybe $1,500 a month. So this is $150 a month. This is triple, right? So 1.8 million. And then maybe you have like 2 to 4 employees. If there's some engineers, let's say you're paying 3 people about $200K a year. We're just going to round that up, 600,000. You're keeping a decent amount of money for yourself, right? I mean, obviously you've got other expenses, office, cloud, etc. But it's probably safe to say you're keeping about 800,000, if not more, for yourself. And you have to consider the fact that, going back to the consulting example, let's say you're only making the $600,000 a year that I referenced earlier, which is actually possible for a consultant too. That $600,000 a year that you're making as a product is worth more than, let's say, the consultant in some ways, because you have a product, meaning you have continuing revenue. So if it's ARR in particular, right? People are paying a subscription, especially for future years. You have more value, right? You could actually sell that. A consultant is going to have a much harder time selling $600,000 of consulting services as something to another company, whereas your product has some value to be sold. So there is value in it, but it's definitely harder to extract. But let's go back a little bit more into code, and then we'll talk a little bit more about the data and kind of what exists and how you can understand this healthcare data. So let's go back to the script here. We're going to go through the DAG really fast, and then after we go through the DAG, we can go through more of the functionality. So we, again, first started with this determine SQL script, which we kind of talked about before. We have to figure out which SQL script is the correct one, right? We got this table, it maps it, it'll tell us which SQL script to pull. You're going to have other things in here too, where honestly, you're not going to be able to just do customer 1 and get to the claims file, because customer 1 is also going to have an eligibility file or an enrollment file, right? You're going to have here, you're going to have enrollment. So you can't just do customer 1. You have to do something like this, and then maybe claims or something, depending on the file. But I'm just using this again as an example, just so you kind of understand that, again, there needs to be some mapping so that you don't have to have 1,000 DAGs to deal with this. You want to have somewhere where you can either build the script. Some people like building it. They put a table and they build it, but basically you have to have some sort of standardized process. From there, we're going to upload the file. So we're just going to use this put command from Snowflake, which just lets you literally push this into what they call a stage, which essentially lets you access this file in Snowflake and treat it almost like a table. So you're going to see that basically when I run this, it essentially puts it somewhere, and then I can grab that file later on with my insert script, which I'll go over in a second. But yeah, so we upload this. This is a Snowflake operator, so it lets us just basically run this. We're calling it a SQL script, but again, it's just running this put operation that we're pushing this file from my local location. So I can actually do this. You can do this too. If you're on Snowflake, you can run the script as well. Then again, we have to have a delete somewhere. And this is why I referenced earlier having that date on there, because to avoid having duplicate data, you're going to want to delete the data from our eventual table that we're trying to insert into. So we're using the file name kind of as a method to track what data we've inserted. Other ways you could do that is by date. You could also do it by ID. That's definitely something you're going to want to do as you go later on, especially in this process. You're going to start wanting to track, the date and the IDs as well, to make sure you're not either duplicating data. So you're going to do either some sort of insert or merge. That's kind of an interesting point, because healthcare in particular can work in different ways, or how the healthcare data works. You can have often either append or a overwrite situation, meaning if they want to change price in healthcare, what you often see is you'll see like, claim 1, claim ID 1, whatever, it's $50. Let's say they changed it because either you have to pay less or whatever reason, claim 1. Now they'll just put like a -25 or something. So now you aggregate this together and you get $25, but it's not overwriting it. You have to do that work, right? So in the overwrite case, you get 2 of these. You get claim 1, you get claim 1. And the way it works, right, is that this is now $25, and you have to know that, oh, well, if I already have claim 1, I have to delete this and replace it. In some cases, that's how it works. In other cases, this is how it works. So you do need to understand how your data set operates. And that's part of the reason you have the standardization process. So we delete that data. Then we want to read the SQL file. For some reason, Snowflake in particular, at least unless someone knows something different, wouldn't let me point it to a file name and then read the file name, which it should work in other instances. So I had to actually create a task to read the SQL file so that I could then pull that text and run the SQL script. Again, in theory, I'm pretty sure you're supposed to be able to do a file name for a lot of other databases and data warehouses, but here I had to literally pull it. So if we go to this read SQL file, load SQL file. I should have kept that name consistent. That's on me. It's exactly what you think it is, which it just takes that script name that we passed it from here. If you remember from determining SQL script name, we pass it here. Then we point that script name here. So we say like, okay, here's the file path. Here's where we're going to look for the SQL file. First, we read it, right? We try to read it, and then we return that data. So that SQL content, we return it. And then so now we're going to be able to pull this from this load SQL file name. So you're going to see that below. So we have this read SQL file. It's looking for the data here, that file name, which is being returned. And I'm going to go open it up that SQL script here in a second. But you'll also see we pass in this param, which is the file name. And this is really where we're adding in that file name to our insert, because that way we can delete it later. So this is how we're passing it with the params. So we're inserting it. Oh, I like keeping this the same, but I should have named it like this. I like trying to keep things pretty consistent, but I didn't, and that's on me. But yeah, so we've got the SQL script, and let's go to that now. And we're going to just insert all of it. So what you're going to notice is we're doing this copy into. So going back to the fact that we're pulling from a stage, you're going to see if I scroll down, all of these are the unabbreviated version of the name, or at least somewhat. I asked ChatGPT to help me unabbreviate this because this is like 180 lines that I wanted to load them all in. Actually, someone called out the fact that like, man, this data is so badly modeled, right? Because you've got this very wide procedure data here. This is very standard for healthcare data. It's going to look like this. We're going to go over kind of how to handle this here and all of this eventually. But for now, again, we're just kind of running it and we're inserting it all. And we're going to want it all because in theory, I mean, probably people don't go this far. I'm sure people don't insert data this far. So maybe we could get rid of it. But for now, we're going to insert all of it. And then we kind of go to the bottom. I'm getting a little dizzy. And if you're not familiar, this is how you treat these stages in SQL. You're going to not refer to their header. You're going to refer to this. You're going to refer to the position, which again, using something like an LLM makes it much easier because I didn't have to go through and go line by line. In the past, I'd do something either where I'd have an automated script or something with Excel to build these scripts because it would be just so chaotic, where I'd have like the data type I wanted and all of that in like 3 columns and then build up this insert. But you can see it stays pretty standard. I do some light transforming here on dates. In theory, this is one of those things that I do like, not doing too much transforms initially. And the reason being that if something goes wrong with this transform or if a file changed, you more quickly are aware of where the problem is, right? Like, is it in the raw file? Is it in the transform? You're gonna know very quickly. But now I want to do some initial standardizing here. I don't think, I'm trying to see if this is a good example. Oh, it's going to be in the beneficiary file. In the beneficiary file, there's going to be a lot possibly of case statements I might need to write in this script as well. And that's, again, one of those places that standardization kind of comes in play, because you're going to have things like different codes that you have to translate to get values like gender. Okay, well, which one, they just give you kind of codes like 001 or something like that. And you have to translate that. And it might be different for different insurance providers or different files that you get from different customers, right? You're going to have to do work and translate that logic. And so that's why you have often a file for each one of these customers, is because hopefully in a perfect world, you'd ask them to name all the columns correctly. You'd ask them to format all the dates correctly. You'd ask them to do all this, but more than likely that didn't happen because they just wouldn't do it. And so if that happens, right, especially if you're pulling from an API, which isn't just going to have different data types and different naming conventions, etc., it's going to have different entities, which are far harder. But at least with this file approach where, hey, I'm asking for files, they'll hopefully give you consistent entities which is great. You're hoping they give you consistent naming, and you're hoping they're going to give general coding that's the same, right? If you ask them for state, you get state and not a state code. But in these beneficiary files, you get state codes that you then have to translate and map to standardized, states. Lots of things being said, I know, but if you're trying to build a product, it's really hard. This takes a lot of work. So we get this script, we insert this data. We kind of pulled that SQL file that we called here, that maps here, customer_claims. Again, in theory, we're going to build this out some more. We're going to add in, so it specifically can handle claims versus enrollment versus drug events, etc. But that's one thing. And now here's a very important thing, right? You want DQ checks. And sadly, I don't think they had a DQ check for this yet. I think in some video, I showed you that you can use like BigQuery data checks. That might be in something that I've made for a different creator that's coming out soon. But there are some data checks. This specific data check is a little more custom. So if I look for this, what I'm trying to do here in this check date quality and validating is, again, you're getting these files from unknown places or at least you kind of know that someone else is responsible for it. At least when you're pulling from an API, you have control of, especially like the start and end date, right? The whole between, like some people are always wondering, like, what does between? Is it inclusive, exclusive? You have control of that. In these cases, when you get these files, you're trusting that someone else who's sending you this is doing it correctly. And I like to think you want to think engineer like Toyota and not like BMW. You have to assume people are not going to do things right. And one of those easy places to figure out, did someone do something right, is the max and min date, right? You're asking them to cut a file. That's actually the terms people often use, is like, cut a file in a certain range of time. Again, we use the example of like, the first month, January. You want to make sure all the data in there exists, right? That means you have data from the start to the end. And it doesn't go out of bounds and it doesn't go too far inbounds, right? You don't want to make sure, hey, why does it start January 2nd? Is there a reason for that? That could be valid, right? You might want to pass that, but you want to be able to know that ahead of time before you do all this processing, that, hey, they gave me the wrong cut of data. It has more data than it needs, and now I'm going to duplicate data later on. Again, in theory, you've built your systems later on, and this is why later on you have these checks where it checks the IDs and it makes sure it doesn't have duplicate data. But again, going back to that append story, if you're appending data, because that's how you think you're supposed to treat this data, then you have a risk, right? Because you could duplicate data. It's an append case, but it's not. It's actually duplicate data, but you're appending it because that's how you've told it to do it. So again, just checking data quality, just to make sure it's got the right data. You could also handle this yourself by saying, hey, only do a certain range, but that makes it harder. I think it's good to just call it out. So basically what this does is it figures out based on the file name. We get the file name again. It extracts the date from the file name. And I just realized that this really only did the first day of the month. I also need the last day. So you're going to check the last date. Okay, so max date should equal the last day of the month. Then you're going to run this query. Then you're going to check and see the max and min date of that specific file. Again, just to double check. Connecting to Snowflake via a hook, which just lets me not have to set up the connection. The connection is already in Airflow. And if it doesn't get a result, because it could just be that maybe that file was empty or something else happened that was wrong. So in theory, that's not why. So you have the max and min result from the dataset. And then you check that to make sure, hey, does that data actually meet the expectations? Should probably name this first date, but just to give you that example. Now from here, you'd probably put this into some sort of data quality utility file so that you can just call whatever data quality scripts you have that are more specific, right? Like maybe you have more unique ones that you're trying to build. So instead of having this in the file, you just import it. And that's what we did at Facebook. We basically had a whole util that was committed to data quality, and we could just call it, and then you'd just be able to say, hey, you just pass it a dictionary and say, run these 8 data quality scripts for me, or these data quality checks for me. That way you don't have to do this every time. Kind of similar to the way that you can with like Google BigQuery's data quality check operator, which I'll put up here. So you check the data, and then after all that, you do ready. The reason we do ready, and I don't remember if I covered this last time, is because then your next script knows what to import. So if you're importing another script after this, you know that you're importing ready. So that's really it. And then we can go check all this, right? We're going to have to go check in SQL. We're going to have to go check Airflow. We got to go run all this. So I'm going to go spin that up, and then we can check it out. All right, so we have raw claims here. We can kind of check this out. I'm just going to trigger the DAG. It's going to run. Again, first, already getting wrong. What? I renamed this and then I forgot to pass it in. I'm gonna have to go through and rename all these a little more reasonable. That's on me. All right, clearly we already started this off on the wrong foot, but we got it going. We've got it running. So it's uploading Snowflake stage. Did that pretty quickly. Gonna delete the old data. It's gonna read a SQL file. Should be pretty fast. Insert into raw claims. Done. Validate data range. This is gonna fail because the file has way more than it. So I'm just gonna mark this as success. I just want to give that example. And then ready is a dummy task, so it automatically basically passes. So cool. This pipeline ran. Now let's go to Snowflake. All right, let's query that data. I'm just query it just so we can look at it and get a feeling for it. All right, we're gonna rerun this again. I had a few rows that I'd missed, and so that was showing everything off. Okay, so as you can see, those negatives are actually correct. That is the number that is put in there. I'm gonna go to the other side just to make sure we have the data in. Okay, cool. Now we actually have the data correct. Before it was clearly not mapped correctly. You can see we loaded it at a specific time. And from there, you also see we have various codes. These are procedure codes. We'll talk about them in a second. We have revenue center codes. We're gonna have tons of diagnosis codes. Most of them blank, honestly. But we're gonna have tons of these diagnosis codes we're gonna have to get into. I'm gonna talk about that here in a second. You're gonna notice that there are both procedure versions of those diagnosis codes. And if I go to the other end, there are also diagnosis versions of those codes. So we're going to talk about all of this slowly, but you really have to understand kind of how healthcare data is tracked to understand some of these intricacies. And same thing with DRG code, which is not drug code. It's diagnosis related group. Again, we're going to talk about all of this, but this is the data. So hopefully that's great, and hopefully you understand that. And now either I'm going to start with the GitHub project, or I'm going to end with it, but I haven't decided. So if this is the end of the video, welcome to the end. This is just the first video. Again, we're going to kind of build a product off of this. And if you want to help, feel free to offer your help because it's going to take some time. I do this when I have free time to actually build these things. All right, this might be at the beginning. This might be at the end. I haven't decided. Basically, I want to talk about kind of what we're going to do with all of this, right? You've noticed that if you looked at the coding section of this video, that I've kind of changed our approach altogether, right? We're trying to build more of a data product versus building just a straightforward set of data pipelines. In order to do that, we need to understand the data itself. Again, there's going to be two key data sets we're pulling from, but they're basically the same data set. So you're going to see here, there's two data sets here. One has so much, millions of records. And so it's going to be great. It's going to be very interesting in that case. The other one's a little bit smaller, but it tracks people over time. So it gives us some benefits there as well. And because both data sets are slightly different, it forces us to have to go through and actually build a system that can process both these data sets and create a standardized version. Again, we're kind of building this product to assume we could handle hundreds or thousands of customers. Again, we're kind of talking about, hey, how can you build $1 million product? If you wanted to build $1 million data product, how would you do it? Again, I've had the fortune of working on several of these products, both where I worked full time in one case and several other examples where it's been, through consulting. But in order to do that, you have to understand, especially with healthcare, the space, the domain. It's not a simple space. You're going to see we're going to cover a few different data set types, claims, beneficiaries, providers, prescriptions, location data. And even in claims, we're going to have to cover a lot. There's going to be a lot of information there. In fact, again, I'm building this project, and if you want to help, and either one, if you have experience in billing, I'd love your help because it'll be really helpful as we build the more specific queries and products off of it. And if you are not as experienced with health data and you just want to learn about it, also great. I'm trying to build below this, some examples of projects. So opioid projects, that's actually stuff I've worked on. Some of the initial projects I've worked on were around opioids and kind of inappropriate prescriptions. Hopefully that's declined at this point, right? We're not doing it as crazy. But fun facts, like one, it was one of the products that I worked on initially. But two, as my family had an adult family home, my poor parents were having to deal with the crazy amounts of overprescribing of opioids because you have to properly dispose of opioids. And adult family homes, you deal with a lot of patients with a lot of different issues. And as a kid, I never understood why my parents either had to go find a service that would do it, or eventually that service stopped existing, probably because so many opioids happened. And then they had to figure out how to properly dispose of it themselves. And it was, very chaotic. So opioids, hopefully that's not a problem anymore. But the data being older, I've already looked through some of it, and it does have opioid prescriptions, so we can look at that and figure out, hey, are people getting prescribed opioids for the right things? Is it too long? One example was, dentist is one space that often is the first place, or specifically oral surgeons, is the first place most of us would have been given opioids. And they were giving crazy long dosages, like 15 to 30 days for getting your wisdom teeth removed, which is far too long. But there's some other stuff, project ideas that we can kind of take on, some chronic condition stuff. But you're gonna have to understand how this actually works. Like when we talk about diagnosis codes, when we talk about procedure codes, like what to look for. So we have to do a lot of work here to find these types of possible analytics. Some other things in here as well. So we're talking about the general system design, which again, I'd like to eventually include the picture of this plus the data model in here. We're going to get there. And then going below that is kind of the important claims concepts that we'll see. So ICD codes, what do they mean? Why is there a diagnosis code? Why is there a procedure code? So that's going to cover it here, as well as talking a little bit about inpatient, outpatient, CPT codes as well, healthcare common procedure codes, DRG codes or diagnosis related groups, and so on and so forth. And national drug codes and a few others. So all that will be here, as well as I need to add in the locations above here for all of these data sets here, because there's claims. These ones right here, claims, beneficiary, prescriptions, are all in one place for the most part. But provider data sets, national drug data sets, in fact, I think it's national drug code data sets. I actually haven't found this one or a good one yet. I found some of parts of them, but they don't include everything. So I will need help. Again, if you want to help in this project, let me know, because I'd love to kind of build this together, because this is one of those things that I will need some help to build these products that we're going to try to build. And we'll kind of talk about the products later in the video, or again, if this is at the end of the video we talked about before. So hopefully this excites you for the types of products you can build here. And we're going to kind of keep building this up. I want to make a series where we're talking about things you can do with data that are real, can translate into money. Again, this is healthcare, which is a little harder, but if you want to build a similar product in a different space that you're an expert in, you can kind of use this blueprint. And that's kind of the idea here. So hopefully this is helpful. Either we're diving into the code or ending this video. So either or, I'll see you in the next step. All right. Thanks all. Bye.